Hi, this is Frank Burke with Dinosaur Rocketry, and today I've got a model that I had built about 10 years ago. This is a model of the Boeing X-37B, which is an Air Force mini shuttle that boosts on the top of an Atlas in a fairing and then goes up, and they carry secret payloads, test new technologies out, whatever they're wanting to do, and then after a year and a half or so, it'll re-enter like a shuttle and come back and be reused. It's purely autonomous. This is about a 1/9 scale, semi-scale model. I don't have the bulged rear end on this one. I kind of tried to do a very simple structure on it, just as a test out the proof of concept. On the real model, it uses fully movable tail surfaces for both yaw and pitch and some roll, and then uses flaperons for roll and drag, and it's got a little flap in the back that they also use for pitch control. On re-entry, it's got some very unusual characteristics. The real one, as it re-enters at very steep angles at Mach 25, there's blanking of the wing where the wing flaperons lose effectiveness or actually have reversal, where they do the opposite of what you want them to do, and they use the tail surfaces to maintain directional control and the tail flap in the back to do the pitch trimming, and then as it slows down the subsonic, it starts behaving more normally. For this particular model, when I built it 10 years ago, I tried just using movable tail surfaces. I do a lot of models with just tail surface control for roll and pitch, but I think the problem I was having was boost was fine, but in glide mode, where it's kind of coming in at some angle of attack, the wing was blanking the airflow over the tail surfaces, and it wasn't responding, or it would kind of snap out after a while. So I kind of shelved it for a while, and just recently I rebuilt this version with just elevon controls, so it's just wing surfaces only with fixed tails, and that's worked much better. It took me a little bit to get the right CG location, but it's not a record-setting glider by any means. It's a fat, draggy fuselage with small wings, but this model is about 38 inches long and a 22-inch wingspan, and it's made with 6mm depron for the tail. It's got formers and a single stringer down the middle, and then it's skinned with 3mm depron that I formed. I rolled over the edge of a table to put a curve in it, and then glued it to the fuselage, and I used some trim vinyl on it for to finish it out, but it weighs just about 10¼ ounces with the rocket motor. It uses a 24mm E6 and boosts to around 400 feet, and we'll do some flights and show you how it flies.
Okay.
Go for it.
5, 4, 3, 2, 1.
Oh, it's a little tail heavy. See that?
Mm-hmm.
It's two nose up. It's going into it. It's kind of spinning because it's too. Yeah, it's just a little too much. You ready?
Mm-hmm.
All right.
5, 4, 3, 2, 1.
That's pretty good. That's actually pretty good, right?
Mm-hmm.
That's almost floaty. That's almost a normal.
Okay.
When you're ready.
5, 4, 3, 2, 1.
Okay, so now I'm just kind of letting it glide in its normal nose down this. Alright, when you're ready.
5, 4, 3, 2, 1.
Keep the nose down, I'll keep some speed up. Get the tail and everything's effective. Kind of like that.
Mm-hmm.
There, that's alright.
5, 4, 3, 2, 1.
Oh, sweet.